When I see motion design that looks this good, I always want to know how it's made. And the good news about this beautiful piece of work was I knew the artist. So we decided to hop on a call and we had a great conversation on how he made such a beautiful piece. We had a few audio issues with the recording, but we think you're still gonna love this conversation with Simon Holmedal from Panoply. All right, here we are with Simon Holmedal from Panoply. Look, I've been saying this wrong for how many years now? I've been saying it like Monopoly, but that's not Monopoly. I say Panoply, but it's Panoply.
Yeah, that's it.
Is that better? All right, yeah. I'm gonna say we're leaving that in. So
it's a real word. It's a real word. It's just no one knows it. And
it's like a lot. It's like a lot of things, or it's like
impressive collection of things.
Yeah. It's like a lot of. Okay, so we got the director of Panoply here. It's Simon Holmedal. Simon, man, I feel like well, I did meet you early on in your career, and why don't you talk a little bit about your early start and what got you into all this motion design and craziness? And then obviously today we're going to dig into your amazing new work that you've been working on in Houdini, but bring us back a little bit to what got you into all this stuff and bring us into kind of college and school when we met as well.
Yeah. So initially, like I found out about motion graphics quite early because my older brother had a company called Stylework, still around. And they took me in as an intern for a couple of weeks when I was like 16, 17 or some shit. And this was like, this was a long time ago because I'm old now, but this was like, no one knew what motion graphics were at this point, more or less. And it kind of just sat in the back of my head for many years. And then when I decided what to do, I just kind of remembered that and like started getting into it. And at the time, I studied an evening course first for 6 months while I was working in a grocery store, and it was the best. I loved it, so I wanted to go full time and applied for a full time program. Unfortunately, it was only 3 people in all of Sweden where I'm from who had applied, so that didn't happen. And then so I studied graphic design and print and tried to do motion on the side. And after a year, Hyper Island opened their first motion graphics program, and I quit my first school after a year earlier. And I moved to this other city in south of Sweden, and then started there, and then I haven't looked back since. And that's where I met you, because you came there as a presenter. I think this was 2009.
9 or 10. I went as a speaker to
9,
Sweden.
For sure.
And it was really early on. Greyscalegorilla was the year of Greyscalegorilla as a company officially started, but we've been doing some videos and tutorials. And this young kid comes up to me and starts asking me Cinema 4D questions. And usually I can answer them when they're new to Cinema 4D, but not Simon. Simon, you had the craziest questions, and I'm like, oh man, you're way further into it than I am. You were in espresso and coding stuff and making all these crazy contraptions, even in 2009. So, and it's just been amazing to watch your career since then. Kind of, you worked, talk about where you've been through Man vs. Machine and where else, like all the way to get.
Yeah, I mean, honestly, I spent as part of that school, I ended up, we had an internship of a couple of months, and I ended up at Man vs. Machine. This was when they were like pretty new as well. They were only like 2-3 years old at that time. And I was then later employed. And I think I was like the 3rd employee or some shit. We were like very small.
I'll get you that T-shirt, Simon. 3rd employee at Man vs. Machine.
I don't know if it was the 3rd, but something like it, and I stayed there for 8 years. So I just milked it, stayed there for a long time. Learned. I just thought of it as an extension of school for a very long time. And then I went freelance for like a couple of months, and then I became a partner at Pumpkin.
I love that period when you're like surrounded. I can just picture it, because this is how I felt, at least at Digital Kitchen, like surrounded by awesome artists, new to it, and just like soaking it all in.
I had 3 months of 3D experience at the time, and they had like 10 years of experience, everyone. I was the only one using Cinema. Everyone was using Maya at the time. It was chaos, but it was and it was super stressful, but it was, I loved it at the same time.
Well, so let's talk about your transition from starting in Cinema 4D, and you were always seemingly like pushing the boundaries of Cinema 4D. You did a tutorial for Greyscalegorilla in 2010, 11, 12, maybe, and those were already like so technical and pushing espresso and like all the dynamics of what you could do. Tell us a little bit about the transition into Houdini, what pulled you into Houdini, and let us know too, those of us who are maybe Houdini curious and using cinema, like what that's like how did that go for your art and your muscle memory too? How was that?
Yeah, so I was kind of, the reason to switch for me was that I kept banging into the walls at the time. Cinema had just released a new feature, which was the cogwheel spline. That was one of their main release points that year. And I was like, I can't believe this. And then I kind of started learning a little bit of soft image exercise. And shortly thereafter, Autodesk killed it. I don't know if you remember this, but they took it and they bought it and discontinued it. So,
yep.
Yeah, so that happened, and that kind of shifted the balance of the world a little bit. And that's when I knew that it was either I stayed with cinema or I kind of moved to Houdini. But I still needed convincing, because I knew cinema quite well, and I was quite passionate about using it. But what happened was that I was doing a project which had a lot of dynamic subdivisions, and I built it all with Express, and it was quite slow and quite cool, but I was using various fall-offs to subdivide a mesh smoothly and divide stuff. And I sat down with Mark, who's now my business partner at Panoply. He was a freelancer at Man B at that time. And I was like, okay, let's build this in Houdini. Let's go through step by step. I explained how it worked, and we built it together. And when I saw how quickly and how easily it was to build that there, I realized that how much time I could have saved if I just, instead of building it in cinema in the first place, we just spent the time learning Houdini, because it's kind of like an investment going forward. And that was my moment when I'm like, okay, because I could change the input mesh and it would just update instantly. It felt like time travel, like I moved forward into the future where softwares were better. But I mean, this was before cinema. It's obviously improved a lot since then. I'm sure if you had all of the new capsule stuff and all that stuff back then, I probably wouldn't have switched. So
yeah, it's definitely got some speed, quite a lot of speed improvements, and the capsules kind of emulate some of that Houdini, almost like you could dive deeper into the software. Sure. But it sounds like Houdini also represented that you could play more and play with it. So once it was set up, you could put another piece of geometry in and see the result pretty quickly. Is it the refresh time too? Like, is the playback a lot faster?
It was like because the way I was building it, in order to kind of do this stuff, I had to duplicate a lot of geometry and then rig it with the Express, and then have another reference that blends with the matrix objects and stuff like that. And it just was a lot of overhead, and it was the old core as well. So it was all like single threaded.
Yeah.
Whereas Houdini was already optimized to run really fast with
that's amazing
cores. So for me, it felt like time travel at the time. And the reusability of stuff, like you can build little, almost like recipes, and then just change the ingredients a little bit, you get a different dish at the other end. I just like the idea.
Now you're talking my language. I love that stuff. When you can set up the Rube Goldberg machine and like put a marble in it and see how it goes through it, and then
you can do that
something else
too. And a lot of times, like with you have some proceduralism there too, but it's just taking that to another level, and it's completely built around that idea of reusability and being able to build little tools and package them up and then reuse them again. Yeah.
That's amazing. All right. Well, maybe I'll call you another day and you could show me some Houdini basics, but I want to dig into your project. Tell me, let's bring us to today and being the director at Panoply and what your day-to-day looks like. And then we're going to dig into your latest project, which is why I'm bugging you today. I want to talk about Manifold and some of the Houdini work that's inside of there. I want to dig into some of your scene files. So bring us to today as far as your career, and then we'll dive in.
So yeah, Panoply, I've been there since 2018. So it's almost 10 years actually. Panoply started in 2015, so it's almost 10 years old already.
That's amazing.
Time just flies. It's crazy.
Nice work, man.
It's a small studio. We're kind of fully remote. We have people spread out and we scale when we need to, but we've always kept this kind of like SEAL team approach with few people, a lot of machines, and a lot of firepower, and then just trying to build things in a scalable way with Houdini and stuff. And yeah, it's kind of an extension of what I was doing on MV. It's been a very similar thing, kind of, but just challenging myself again, because I was a little bit on autopilot at the end. It felt I needed a new challenge, and this was definitely a challenge. So yeah, no, we've been busy, and we've been working with a bunch of.
That's awesome. So let's do this.
Yeah.
Let's watch the full project all the way through, and we'll just talk over it. So I'm guessing if you want to see it without us blabbing on about it, we're going to obviously have links and all that down below. But let's let's try
audio by Human Rule, so good friend of mine as well.
Why don't you hit play and we'll look at this beautiful thing. So all in Houdini, and you said a little bit of post, but I just love this stuff.
So the idea behind Manifold was it's kind of like to record the intersection of a higher dimension. So if you imagine a 3D or 2D character that lives gets intersected with a 3D object, it would kind of create this slice of the 3D shape and have that drive various dynamic properties of the fabric. So this entire project is just that exposed, basically. It's the scanner that goes through these simple 3D objects, and they record information about them, and then that translates to a 2D object, which is the fabric, that then gets displaced and reacts accordingly to the state of the 3D scene. So it's this kind of multidimensional journey between those two worlds, and then visualizing it with a bit of nice kind of retro aesthetics. Kind of brought in a Commodore screens with a bunch of pixel effects and stuff, because I just love the old CRT pixel effect you get. And then we wanted to play a little bit with some of the new rasterization stuff in 20.5. So like being able to record geometry directly without rendering it in a way. We can talk.
So that effect at the end is all Houdini as well, right? That's what you're mentioning. Some of the
Correct.
new,
yeah, exactly. So all of this recording. So these are like the intersection of the various meshes, for example. You know, this is not a render necessarily. This is a recording of the intersection of the UV map with a mesh in the 3D scene. Does that make sense?
Oh, you were mentioning that with the cube box, right? You're like scanning through it. Oh, there we go.
You can see here. So this is kind of like what I'm talking about. So this is looking at the UV map of this grid and essentially sampling the distance of any given pixel to any object, and like sampling the information of that object onto textures that then can drive the fabric later on. That was the idea, like the intersection of two dimensions, right?
Yeah, I see. So this is what's on the TV. This is what's on, and you said this is what's driving the cloth systems?
Yeah, exactly. So these are different.
Oh, I see.
This is the data that's kind of visualized. But yeah, this is what's driving the cloth systems. Exactly. So that was
like
kind of the idea. Yeah.
Like a 3D scanner going through the shapes, and you're representing that data differently on the TVs and then in the cloth as well.
Exactly. So the first test I did was I just want to learn a little bit more. I always build like stuff with sub solvers, and which is like you build your own solvers from scratch kind of thing. And I was never that comfortable with a lot of the built-in solvers. I didn't really know how to use them. So I wanted to do something with Vellum, but I wanted to do something where it kind of has another dimension to it. So I started by just recording data like this. So this was just an orthographic camera in an isolated scene. And I just put a bunch of cubes and spheres in a invisible cube, and I just rendered them. So this is like the raw render itself, and I have the scene files you can look at. But this is just a simple rigid body sim with some noise, wind basically. And then from that, I started.
By the way, this is when I'm playing around. This is where I stop.
Yeah,
I'm like, I got my shapes and my cubes, and then you took it and we're like, all right, I want to scan this in 3D.
This is the result of that test. So I wanted to play around with like with the idea of transferring that information across to this other 2D dimension and allow that drive in the fabric. Because nothing wrong with inflating shapes and stuff, but we've seen it a few times, and I wanted to try something.
So this is the last one you showed, right? The orthographic like side shot.
This is the same thing as this.
It's this.
It might be rotated a little bit differently.
Yeah, and then every shape is like what, a different type of cloth, or they're it's like defining the cloth boundary, and it has different settings, so you get all these pinching and stuff like that. Is that
even at the overlaps of the different shapes, you get like different properties of the fabric as depending on what shape is visible, and you get this. So you can sort of see that the spheres are kind of shrinking and pinching the fabric, whereas the cubes are expanding it, and then there's the intersection of the two as well. And then there's different material properties that carry over that as well. So we're not only using it to simulate the fabric, and there's another alternative version here as well. So this is the one with the performance fabrics. The first one was more like felt materials. These are all GSG materials from start.
Oh, this is the Greyscalegorilla, the performance fabrics collection.
Yeah.
So that was out a few months ago. So I see it. It's got all the
I think I'm also, to be honest, I think if I'm not mistaken, I could be wrong. I think the cubes are actually using a rubber hose material, but like slightly different color. But they're all from the GSG thing. Just changed.
That's awesome. It's so cool to see our stuff used in different ways. You're like, it's built for a specific object, but you're using it in such an abstract way. So that's super cool to see that. Okay, so this is the same, but with different materials and different settings. Oh, I see. And they both got.
So here I just stuck them on a cube. I was just playing around with this stuff, and then I took the actual render of the first thing and created it into like a little sticker that sits on the.
Yeah, that's trippy. It's like a 2D version of it stuck on the wall. So it plays perfectly from the side, but then it reveals it shows the stickerness of it as it turns.
Yeah.
Okay, so these are all the same projection type, and you're interpreting it in different ways, or you're setting up the cloth systems. So it's actually 3D too. Like, that's not a sticker of the cloth. That's actually
so maybe around. I wasn't clear what I was saying. So this is a 3D cloth, obviously. But
that's cool.
But on the foreground, you see it's kind of like that render, and I just put a little
that part's the sticker.
That's the sticker part. So so this was just I was just having a bit of fun. It's not too serious, so I was just like playing around, and this was just a visual that I thought was kind of interesting.
You mentioned a little bit of this, Simon. When you go into a project like this, was this because of what you said earlier? Like, hey, I know some of the setups, but I want to learn more of the vellum, or like, how do you structure a project like this around what your intentions are, what story you want to tell, or even what you want to learn? It sounds like there was some like specific stuff in here that you were like, I want to figure this out, or I want to make sure I play with this part of it.
So as I said, I just had this idea of intersecting, driving it with something different. So this idea came from just the idea of taking it to the stream and making it out of 3D objects, but having that drive the vellum, because I wanted to learn vellum a little bit more. I hadn't really messed with it enough, and I just thought this would just it's just a little bit of a spin on a normal vellum simulation. It's just a little bit of a different take on it. And then I started thinking about, okay, what if it went through physical objects? So that's when I built the scanner. And then I wanted to tie them together. So I added this rotation of the scene. So you'll see here, it kind of starts creeping and spins around. And I added that same rotation in the in the monitor scene using the same cameras and everything. So everything feels like they have a dependency that link them together as a kind of cut point and stuff as well.
I see.
Yep. And then we also have I think maybe I don't have it here, the actual fabric itself. Oh yeah, here. So here's like, this one is 16:9 for whatever reason, but or 9:16, but you can sort of see that this has the same rotation as well. So they're all linking with that stuff. And then the edit just became what it is because I started messing around with intercutting various layers of this together, and it just became a mishmash of it.
Yeah, but before we dig into the scene files, talk about your editing process a little, because it sounds like you get all these pieces and ideas together first. So like, do you have an idea of what the end edit's going to be, or do you kind of experiment and then put it all together at the end?
Normally, yes, but in this case, no. I just knew that I wanted to tie together the monitor scene and the scanner and the actual fabric itself. And when I had the monitors, I realized it was quite nice to intercut and really get to see the data up close like this. So that
I love those close-ups.
A nice layer, a nice textural element to it. And then that led me to like start to explore various consoles data here and like glitches and stuff. So this is like all this here. Simulation, natural simulation, OS3, Panopticon. This is all like, so this is where I have actually utilized a bit of AI ChatGPT to generate all this gibberish that go into that.
give me gibberish code to put in.
Yeah, exactly. Project. But I didn't. Yeah, so it is. I'm being honest about that. Like the code is not written by hand like this, but I did like direct it to tell it what I wanted it to be about, and there's a lot of weird gibberish there, but it was kind of fun.
That's beautiful.
And then I just played around with it in Resolve and just added some,
there's some scenes toward the end too, Simon. I wanted to ask you about. They're like the 3D pieces. Yeah, like. Yeah, how did this tie into your idea? It looks like it's similar, but it's, was this an experiment, or how did you approach this piece?
So this is a very similar thing technically, but it's a lot more fabric, so it's not as detailed, which is why I didn't use it too much in the film. I just used it momentarily. I also created a kind of squiggly version, which is this. So yeah, this is. I have this files as well. The idea here was, instead of shooting using a 2D object, a flat intersection, I used the kind of normals of the surfaces to shoot a ray into the objects and then have 3D objects nib within the shapes, and then have that dry the fabric. So they're not physically there in this dimension, if you know what I mean. But there is a parallel version without the movement of the fabric, where I've just taken the normals of the surface and essentially shot the ray inwards to hit the various shapes. So that way, if you have a little bit of smooth normals, it kind of distorts and almost refracts over the surface. And it kind of creates this weird metaball version of the 3D shapes. So that was kind of the idea behind these. And I actually set up with like P2G, which is a way of taking proceduralism to another level again. So I actually have like 6 or 7 or 8 different seeds, shape 6, shape 3. These are like just different seeds of the same system. So that was kind of automated. So I ran like 8 different ones and just picked the best parts later on. Yeah.
This is a little technical beyond
I know I didn't
part, but no, I mean the all this is for my brain. But when you have an idea like this, are you setting this up, kicking off a big overnight render and seeing how it looks, or are you doing like really low res or low quality tests to see before? Like, do you have to see it in full, like high res to know
I
if it's
literally
working
didn't
or not?
even. I literally didn't even know what shapes would come out, and then I just kind of set up one little test.
Yeah.
With this like slightly small shape, but with the same settings, and then I just set it off overnight on like a few machines.
So
DDG kind of handles that. You just give it seed values, and it kind of changes some noise patterns and different scatterings. So the structure here is basically shapes scattered onto shapes and then booled together.
and what's that called? It was an acronym, PNG or something?
PDG.
PDG.
Procedural dependency graph.
Okay, so back to your earlier when we were talking, like you wanted to set up the the machine and put different inputs in. It sounds like that was this idea too. Like, hey, let me put in a different set of geometry or whatever in the front. Let it render overnight. You don't even roughly know what's going to happen, but you come back and you're like, that's interesting, or it's not.
Yeah.
And
it wasn't as interesting as I wanted with these 3D shapes, to be honest, which is why I only used it momentarily in the film. But I kind of prefer the detail you get from some of these where the resolution of the fabric are just more intricate, because it's not as scaled up.
Thank you for sharing those quick times. Like you have all these pieces and tests and renders, but let's dig into one of these scene files. I'm sure I'm going to ask you some hopefully good and some dumb Houdini questions as I learn along with everybody. But why don't you dig into one of those ones? So tell us what scene we're looking at here, and tell us kind of how this flows.
Yes, sorry, interrupting you there. I've just brought a few of the different parts into this. So this scene has a lot. It's not everything, but it has a few of the parts. So we can look at my first test first, maybe, which was the 2D shapes and the 2D render of the shapes. So I had nodes. Yeah, sorry, this is not super tidy either, so I do apologize. But
just first dumb question, starting in 3, 2, 1. Are all those nodes just for this scene, or all those nodes represent the entire project?
This is just for this scene. This is just for this.
That's amazing. Okay,
it's not. It's just very poorly organized.
No, I'm like that with nodes all the time. I'll even material and texture nodes, I'll be messing with them up close and I know what all of them do. And then when you zoom out, you're like, oh, I didn't know I made 50 of them. So I'm assuming that's also kind of similar. So sorry to interrupt. Why don't you show us the
I'll show you what this is actually. So it doesn't just look like I'm trying to hide behind a bunch of weird setups, but this is somewhat basic. So it's a cube that I'm scaling to be tall like that, and then I'm copying it around so that it's kind of a tunnel like this. See?
That's cool.
So we're looking down this camera here, or this tunnel later on. That's the idea. And then I'm taking this this and I'm creating a bounding box around it. So now it's just cubing it. And I'm creating a volume from it. I'm shrinking it down, creating a volume from it, and then scattering some points in it. And these points then take on some cubes. And then I'm doing the same again. I'm scattering some spheres. And they get merged together. They then get simulated into a rigid body sim where it's colliding with this original tunnel. So that's all there is. All of this stuff here, that's the result of that is this basically.
Simon, I'm so glad you just did what you just did there. Like the big pieces of what all these nodes do. Like, all right, here's actually just all the geometry where it looks like you're in Cinema 4D terms, like cloning onto those dots and creating the geometry. And then for the sim, is that a bunch of code in here, or is that like a node you could pull in and go like, yo, be dynamic?
Yeah, basically. A rigid body configure, and then there's a rigid body solver. You're just plugging it in. I literally don't know much about this. And then I would say this is the solver itself, and we can see it. We can run this live and see how stupid of me, but we might be about it. But yeah, this is all I've done is I've gone in and added a little wind force with some noise amplitude. Just just a normal.
Okay. So this is like the setting up the world dynamics and the wind.
Yeah,
and
and I turned off gravity here.
Got it.
There's some stuff on the top level.
Classic MoGraph move, man. You got to turn to get rid of gravity.
Yeah, we don't.
We're not trying to do a realistic sand sim here. We're in outer space, baby. So that's going down and creating the dynamics.
Yep. And so sort of my viewport is locked up.
Yep.
Here we go. Yeah, so that's happening, and you can see it's actually simulating now. And this blue bar down here shows that it's simulating. So it's actually running it live. I thought this was cached, but apparently not.
So is that Houdini saying like, hey, I'm going to pre-render kind of where we are so that you can see the result?
Whenever you're running anything that's simulated, it's kind of, when you're previewing it, it creates this blue bar, which just shows that it's kind of cached into memory. And then
that's cool.
Then you can cache them out to disk, which this should be doing that. I don't know why it's actually showing me. So I'm just going to turn off this little brain down here, which is disable simulation, and hopefully that should make it a bit quicker.
Okay.
And this stuff we don't really need to go into. I was just adding a little bit of I say that and then I click it, which is a good idea. Basically, this was just to make it render a little bit differently.
Okay.
Because I wanted them to be more faceted and look a little bit lo-fi. You know that this is going to show my age, but you know the Amigas, the old computers, coming around.
Oh, yeah.
Amiga. They had this bouncing sphere demo that was, their kind of hallmark thing, right? That was kind of a part of the inspiration for this, actually, in a way.
And it was like the gridded sphere.
Yeah, exactly. It was just bouncing, and people were like, oh, it's incredible. So that was kind of the idea of just keeping these really primitive shapes and also, tying that into what's it called? The Commodore screens and everything in the film.
Yeah, all the close-ups. That's great.
Yeah. So this is I now just imported that scene here in Solaris, which is lighting. It's also called LOPS. So I know I'm kind of jumping ahead, but there's different contexts. I don't know how deep we want to go with this thing, but
no, this is great. As long as the audience doesn't mind, the people watching that actually know Houdini are going to be like, Nick's asking dumb questions, but this is fun if I'm learning too. So it sounds like all the geometry is built here in this world, and then you're bringing it into SOPs, which I've played with a little bit, but that's where you light and your cameras, and that's kind of, in my mind, where the studio starts. Like all the manufacturing and building of the props is in one part of Houdini, and that's what you just showed us. And then
so this is actually
you bring it in here to set up your lights and your cameras and your passes and your materials too, right? That's all in here, basically. Exactly. All your look dev.
So this right here, where we were doing the modeling and the simming stuff, this is SOPs. So that's those stands for surface operators, and LOPS is lighting operators, basically. So it's the lighting and the rendering and the materials. And the beautiful thing about this is when you bring it in, you create your materials, you can assign, it shows up here. This is built on USD, which is Pixar's kind of scene description. But all different pieces come in here, and I can then assign materials to them. And then you can set up some lighting, and you can branch it and create different versions of the scene. So you see here, these are two different branches. So I can have different render settings, different lights in different branches if I wanted to. There's stuff like the light mixer, which is literally like a mixer for various lights. I don't know if I have any lights here. I only have one light, so this is not the best demo, but you have like sliders and stuff. You can imagine you can control.
It's like a audio mixer.
Yeah, exactly.
I love it.
You can have different lights and then have different mixers for different shots and that sort of thing. So it's quite. You can follow the flow of the scene.
Yeah, so I've played with this a little bit. We've been making Greyscalegorilla Studio, and it works in Houdini and Blender and everything. So I've been learning a little bit of the basics to understand the workflow and make sure everything's working well. And what I love about this part is it let me set up different lighting scenarios like they were just different parts, different worlds. And then just like you were showing, like I could just switch between them really quickly, and set up entirely different lighting setups, entirely different material setups, and then just click with like one click, jump between any mixture of them. I just love that part of that.
And you can also render and see the AIVs here. So like see the render passes.
That's so cool. Okay,
so now we have these AIVs. That's what I then wanted to feed into the materials, but also into the vellum stuff. So we can kind of move on to that.
Let's dig into vellum. So vellum is vellum only? I shouldn't say only. It does a lot of stuff, but is it primarily cloth sim? Is that vellum?
No, you can do. I mean, vellum it's known for fabrics and cloth, but you can do like sand. You can do rigid bodies and stuff as well in it now.
So it's like an advanced simulation world. People just use it a lot for cloth. It's kind of known for that, but it does everything, right? It does rigid body and sounds like particles.
Vellum configure. So if I do vellum configure, you see here there's a few. You have hair, grain, fluids. You can do soft bodies. You can also do rigids. I don't know why they don't show up, but you can do rigid shapes as well. So they can kind of interact with each other all in one sim. But in this case, all I was doing was creating this fabric. And I mapped these various textures. So these are the render passes that I've just broken up into the red, green, and blue channel. I've also done a little bit of edge detection on it.
Oh, nice. So you can like pinch seam or create seams and stuff like that with this pass.
Yeah, exactly. So these are the three that is actually affecting in this initial test. These are the three passes that I loaded in, and I've kind of transferred them over to the
Simon, are those pre-rendered, or is all this flowing through from the original?
So in this initial case, it can be free flowing. In this case, it wasn't. I rendered it out a sequence, and then brought them in here.
Got it.
So I loaded in. So this is applying the boxes. So you see here, this is the texture, and this is kind of applying it to attributes here. So if I do box, no, it's not called that, of course, but it's called boxes there. Box start. No, I can't type. There we go. Boxes. You see here, this has zeros for the most part, but it has other values where it's like not black, basically. So that's just being transferred over to the points of the grid. So you can see here, this is a very dense grid, and you can see it's represented as color, but it's also has this information called boxes on the grid. And that's just using the UV map of the grid and then applying the color map and storing it as boxes. That's all I'm doing here.
Okay. Yep.
And doing the same thing for the spheres. So there they are. And then for the seams, which is the edges, the overlaps. Excuse me. So that gets carried over to the mainstream, which is just here. So every frame, you can see this little stopwatch here. That means that this is time dependent and updates every frame, because the spheres and boxes render their sequence,
Got it. So look at that frame and recalculate every frame.
Exactly. So then all I'm doing is I'm using that to control stuff inside of the solver. And without going too crazy about this, it's reading essentially this point here, sample attributes, that null object, which is just holding all of those attributes, spheres, boxes, and seams. And then in here, in this kind of blob here, this is where it's reading the data in. So I'm using a rest position, which is essentially just the first frame of the fabric before it started moving. If that makes sense, before it goes into the sim, just stored that information.
Yeah, like set your start frame.
Exactly. And then from that, I'm just looking for nearby points on that null object. And I'm looking up boxes, spheres, and seams. And then I'm just manipulating some attributes within the solver itself, specifically in this case, the rest length, which controls the length of the constraints between the different points on the grid. So if you imagine a triangulated grid, if you look at that here, if this computer will cooperate, if you imagine the fabric is just trying to keep, if this wasn't a stretchy fabric, you would have a quite stiff constraint that tries to maintain the distance between the neighboring points on the grid. And if you were to expand the rest length, this line would like to be bigger than it is originally. Hence, it kind of starts to bulge out, and fold on itself.
This is where you were saying the spheres were pinching, like making it tighter, and the cubes were making it more floppy. So you get these push-pull.
Exactly. And if you look at the seams as well, when they overlap, there's a little bit of pinch even when two cubes overlap. And that's just because that edge detection is playing a part as well in manipulating this attribute. But you can really see the pinch here when you have like there.
Yeah, I see. So the sphere's pulling it in, the cube's letting it out, and those two kind of interact, like give it the space to wrinkle on the outside, and then also tighten it in on the inside. So it's always moving.
Yeah, so that's basically what that means, and that's why I want to show you the triangles there. But all this is doing is using rest length orig, which means original rest length. This is a default attribute that lives in Vellum, and I'm just scaling it down. So this is a multiply, so I'm multiplying it up by 1.7, so that's almost 170% of the original length. And it's doing that only if it's a box, Yep. So that's the first step, and then it takes the spheres, and then if it's a sphere, then it takes it down to 1.7%, so 0.017 percent of its original length, and then do 60% if it's a C,
Yeah, it's a little, some of the new cloth stuff in Cinema 4D has the ability to read vertex maps, and you could do some basic stuff in there. So you could like set up a vertex map and bring it in and say, hey, wherever this is red, make it extra floppy, and where it's not, tighten it up. So you could do probably not this like with this much interaction, but I guess I'm just understanding the concept more.
Here you can see the seam quite well now that I don't have the texture on it. So that's
so what's the seam? Is the seam like pulling it tight and like folding it?
Yeah, so this is the edge group that we looked at. So this is this here. Remember?
That's funny. So what's the settings on that? Is that like pull it really tight?
That's 60%. 60%. So it's not as tight as the sphere. The sphere was like 2%, but this is 60% shorter. So it's not as disruptive, but you can see even when two cubes are overlapping, you do get that interaction. And that,
you get just like a piece of fabric, you would fold it over and like, sew it for a second, like you get a little fold.
Yeah, exactly. And to your point with what do you say?
Oh, the vertex maps and all
that. I mean, here I've just broken out. This is a composite network here. I've just brought in all of of course it crashes. And this is where we pick up in a minute. Yeah.
All right. We had a quick crash there. We're back. It was quick to load up. So where were we? We were talking about, you were showing the breakdown of all the final kind of maps here.
Yeah. So these are the three maps that we used, or these are the maps that was used for the same, like we just looked at. But these are all of the various AOVs and layers that I exported that then go into shading. So you had a question earlier about if it was live or if it was loading directly from render. I wanted to demonstrate for you now that it can be live. So this is a little bit crazy, but I've set up a little separate network here in Redshift. This might need a little bit of time to like reinitialize now that we've kind of started this up again. But this has been set up with GSG materials. It has a little bit of a different look because I was just wanted to demonstrate this. But I've also brought in some of this data live now. So you're going to see there's a few additional lines and dots and crosshairs and stuff in this render once it actually starts. That wasn't in the original, and while that's loading up in this. So it's going to look a little bit. It's going to look a little bit different than this, but it's using the same sim. It's using the same passes, but I've also used the new Copernicus, which is the COPS context. You can sort of see here it has some kind of bounding boxes around them, and it has some weird dots emerging and stuff like that. And it's a little bit of a different look. But I wanted to show this because you can reference data live, and these boxes and these crosshairs weren't part of the original render passes we just looked at. They're being generated.
That's all being created. That's all being created now.
Yes. So exactly, and I can show you really quickly. So these are some of the materials from Greyscalegorilla that I brought in, and then I've copied them into one big kind of blend material, that mixes them with all of these different masks. So we have like those maps that we just looked at in earlier. So plus a grid, a kind of tile grid, but the spheres, the boxes, the wireframes, all of these things. And then I have these additional ones. So the cross UV pattern and bounding box. This, notice, has like an OP in front of it here in the path. I don't know if you can see that, but
oh yeah,
that means that means operator, and this is actually a path to a live texture that is being pulled in and created live. So that's now adding some additional stuff. I've also used them here to kind of mix colors and stuff. So
I'll say it. Let me say it back in my language just so I understand it. So you brought in Greyscalegorilla materials in Redshift, and then you broke out some of the different parts of the materials that you wanted being affected differently, and you brought in live data into the actual nodes of the material to drive the material slightly differently depending on what the input was, and then you run it all through this mixer to output the final piece.
More or less. So like each one of these blocks here represents one of the GST materials, and it's a simple layering where you just have a blend value. So it's like layer by layer, mixing in with an alpha on top of each other, and the end result is one material that holds all of the materials, and they're blending.
Oh, I see. That's bringing it in for the alpha for each one. So, hey, the yellow material, or you had like performance fabric in there. I saw that one's only applied to this part. And are the characteristics being built in here, or that's all being done in the Vellum solver, right?
Yeah. So the movement is already defined at this point. But what I wanted to show you is this kind of crosshairs you see here and the dots and stuff. That stuff is live, and I'm going to show you what that actually is. So that's if I take one of these three up here. These are using this color is called cross. So if I just plug this directly, I feel we can render that. If Redshift is going to behave, it's been not behaving too much today, so we'll see. But you see there, this is like the crosshairs on their own. So I'm going to show you, because that's not saved to disk at all. That's a live link, and that's all happening here. So this is the new Copernicus, so the new compositor in 20.5, the new version of Houdini.
Oh, so that pattern is built in Copernicus?
Yeah, this is a live pattern here. So you can see here, this is, if I go into composite, this is here. This is like an SDF shape, which is kind of similar to a VDB or a volume builder in cinema, but in 2D.
Okay.
So if I expand this, you see that gets bigger, and then we can convert that to quote unquote a surface, and it becomes this 2D shape. So I can shrink this, I can make it bigger, I can do whatever, and then I can tile it in and put it on a bunch of shapes at different tiling. I'm going to show what these shapes are coming in, because it's not just random shapes here. I'm actually using I've imported the same camera that was creating the initial layers, and I've also imported some geometry. So I've taken those original things we looked at. If we go to the scene view here, remember these that were moving around?
Oh yeah.
Yep. I've basically gone through each connected piece, so each cube or sphere or whatever, and created a cube around it. So this gives me this. I also added some automatic UVs on them. So they're just moving around now, and they're always holding, it's kind of like a bounding box of you see there?
Oh yeah.
So then I took these UVs and I froze it on the first frame, so I can just have like a fixed reference point, and laid out the UVs. So if you now look at the UV here, so they're all laid out. And then I've copied that back. So now they're stretching and being all weird, but at least they're just there and they're fixed to these objects. Scale the UVs a bit so they're tighter. And then I took this attribute class, which is generated from this kind of loop. Basically, the way it defines which one is its own object, it just checks connectivity, and it then creates a attribute in this called class, and that's how it can loop over each one. I'm taking that attribute and essentially creating a new value called ID. So if you look at that here, I mean, it's what we just saw. Where they have different colors. So each one has its own number. Let's see here.
Oh, and that's what's getting each. That's where the pattern's coming from.
Yeah, so that's where the color came about when they had random colors, which my viewport is not happy with me right now, of course. But we can see here. I'm going to get it back. There it is. See how they're different colors?
Yep.
That just means that they have unique values for each object. That's the ID attribute. So now these cubes are basically, they're importing that live. We're taking the camera and we're now filming them essentially with that camera again, live. And we're reading out the IDs, which you can sort of see here, if you see on this preview there. See it here as well, if it behaves. So these are represented by a random color now. You see the seed value here is taking that and it's just generating a random color. And from that, I can create edge detect, because they have different values, so they can do an edge detect. And that becomes one of my textures and then referencing directly in the shader. I'm also taking the UVs. So these are the UVs on the cubes. And now I can apply this cross that we had onto them. And we can change this to, I don't know, be another object or whatever texture you want. Now it's a circle instead. Just to prove that it's live, we can keep the circle here just to do it again. And here I'm doing the same thing again. I'm taking the geometry, which is this again, just straight. I'm not doing any bounding boxes or anything here. Same camera, and I'm just getting as an alpha channel, again. And this wasn't rendered in advance. I'm just creating that live, and I'm inverting that so we have this kind of mask, and then I'm taking that and multiplying against this. So if we look here, boxes, and now we're cutting that out, right? So now we have, it's called cross because it was cross, now it's circles, and we can even use this preview material with the mesh itself to see what this would look like on the mesh laid out. So you see it there directly live. But this is also now, this null here is referenced in the shader. So if we were to fire up Redshift again, in theory, we should now have circles. Fingers crossed that worked.
Here we go.
Yeah.
Here we go. A, we're doing a live. B, it's all procedural here. And so it's got to build it all, and we get to change it that quickly, which is really cool.
It's also, the fabric is quite heavy, and there's a lot, millions of polygons on it. But there you see it. Now we have circles instead of crosses. So, yeah.
Beautiful color. We got that nice salmon kind of pink going on. It's beautiful.
Oh, yeah, I forgot. I have another layer here as well that I was doing. So we have another one, which is kind of crazy when I'm just down here. So I took same method again, bringing the data in. So this is the normal direction of the surface. I'm just taking the Y value, so it's like pointing straight up because this camera was just looking down on this.
Yep.
Using that and kind of clamping it so you have like a quite harsh fall off. I'm now mixing between two different patterns. So I'm taking the UVs of the original shapes, which are coming in here. So this is the spheres and the cubes and the UV maps. And I'm mapping essentially a circle onto it. I think I created like a triplanar UV map, which is why it's kind of stretching a little bit. It's not perfect. It might be a cube map, whatever. It wasn't that important. It was just a test. But
yeah, I just wanted to test it.
Yeah, and then another one with triangles. And then this kind of creates this map. So based on using that normal, we can now mix so that the ones that are facing us are circles, and then on the edges we get the triangles. And then here, so then I took in this, before I imported it in, I created a ambient occlusion sort of attribute on the mesh. So you can sort of see it here in color. It's a little bit hard to identify. This is one of those tools that we built ourselves, but we can package up, see it has stuff inside of it, whatever. You can, any attribute you create, you can read in here. So I just created an ambient occlusion. And if we look at that here, we have, this was probably a bad frame to look at, but there you go. That's a bit better. You see this kind of occlusion that's happening there between this sphere and that sphere. And now we can use that together with this to kind of mask that in. So there you see. So now that only emerged there. And this is also referenced in the shader. So if we manage to fire this off one more time, we should hopefully see that as well.
That when you're going through this, are you envisioning the final piece and then using the tech to build it, or are you inspired by the tech of like, oh, I wonder what ambient occlusion would look like here, or I wonder what messing with the UVs would look like here? Like, how are you experimenting and thinking through using the tools here? Does that make sense?
Yeah, it does. I mean, in this case, it was just to try to give a demo for you guys, because this wasn't actually used in the film exactly like this. It was just to show the potential of bringing stuff in live. But I'm going to be honest, this project was a lot of just exploring what would happen if I did this kind of thing.
Yeah, I love that.
There you see the occlusion happening.
Yeah, so that's blending between both and the occlusion. Yep. That's really cool. Well, hey, let's why don't we finish with this, Simon? I could do a deep dive into any of these pieces, and I think we'll definitely have to call you back and ask some more specific questions about Vellum. If you're watching this out there and you have questions about anything that you've seen, throw it in the comments. We'll try to get to it and maybe do a follow-up with Simon. If you're looking at if you're new to Houdini and you want to learn more, put it in the comment. Hey, show me how to use Vellum, because I'm going to try to convince Simon to show me some basic cloth setup or something somewhere down the road. But let's finish with this. We talk about this all the time in our videos and tutorials and at Greyscalegorilla, which is the major pieces of any 3D project that make it look good. We love helping make it look good. And we know that materials are a huge part of that, but also lighting and cameras are a huge part of that. So why don't we take this scene or the cloth scene, whatever you want to show off, and can you show us your basic, like what your lighting and what your camera setup is for something like this? I always find it interesting to see how this is set up, and I think it's just really helpful whenever you see something beautiful to say, hey, where are the lights, where are the cameras, and what materials are you using?
Yeah, for sure. I just need to figure out how to show it, because it's a little bit less responsive to look at here.
You turn it all on.
But I mean, I was thinking maybe the best way would be to actually bring in the render into Nuke and just look at it, or like in layer by layer. But we can also just look at it here. So Let me turn off. I don't even know, to be honest. But in this case, we are illuminating the scene by, if we're just looking at this scene, for example, I can bring it up here so we can, so I have the scanner blue. So this is actually just illuminated by the actual texture itself that illuminates in scanner. So this is one of the light passes that were outputted. And this is only lit by that material that is see now okay, there's a little bit of background light, but it's so minimal. It's like a little bit of it, like 2% of the HDR for some reflection.
Yeah, this is like the ambient occlusion style pass, right? Like wherever it's touching, it's glowing, and it looks like it's also surrounding it too.
It's bouncing around. It's using all GI. It's path tracing. This one was rendered with Octane, so it gets really beautiful bounce lights and ACEs take care of like hotspots and stuff. It has nice fall-offs. Heavy to render though, with all of this glass.
Yeah, with glass and the metal, and then and it looks like some pretty straightforward materials here. We got metal and glass.
Yeah, exactly. So we took. You can sort of see the hammered metals. That was one of the GSG material.
Oh yeah, I recognize that one. That's the hammered from the EMC collection. I think the hammered metals there.
Yeah, that was like a really nice touch. I remember. Do you remember in Interstellar that big AI robot, which is it's a robot in the ship. It looks like a cube.
Yeah,
it has some really nice textures to it, but it's so simple. And that was kind of a little bit of an inspiration for what type of materials were used here. I also wanted to have like a little checkerboard, which is a reference to that Amiga thing, but also like the fact that this is very much a test subject.
It's like a crash test dummy.
Exactly.
Yeah, and it's like just emergency warehouse, like where the clean your eye station is, like the fallout shelter is.
Exactly. So it feels a little bit dangerous. I imagine this is like somewhere in like Area 51, and they're trying like anti-gravity technology.
Yeah. That's great. Isn't that amazing how iconic some materials and textures can be, that just like a yellow and black checkerboard can mean so much. And
it's because subliminal, right?
Yeah, it's subliminal, and we don't even think about it when we see it, but we have that like, oh, this is like we're in a testing facility just by seeing that. It's so cool. Okay, sorry, I'm taking you off. So
I just brought this up here because this is maybe a good example, because this is for lighting. Because this is using primarily a backlight. You can see there's a cyc in the background, and that's been illuminated. And that's like 90% of the lighting. And then there's just a little bit of red fill light in the foreground. And the rest is just off the screens. So I like this kind of when it's like underlit almost, This
it's dark.
There's a little bit of light here, right? So, but
go to the rotation, Simon, because you have like a light off to the right there. I saw reflected in the TV and on the side. So there's something off to the right. Is that designed for that part, or is that what's lighting the background?
It's a little bit of a fill, but it's not specifically for that. A lot of it is also just the bounce of the background. In this particular example, I had quite a strong light quite close to the background, so you get a little bit of fall off.
Yep.
It's not as noticeable because I initially lit it for a 916 format.
Yeah, but you get that even that left to right fall off.
It's a little bit of gradient.
Yeah, gives enough of like, okay, there's obviously a light over there. It sets it in a real place, and that stuff's so important. Whenever I'm thinking about what's missing in lighting, it's often just a little bit of gradient. Can you talk about how you light and maybe some of the thought process here? Like, hey, this should be darker, this should be lighter.
Yeah. Yeah, I mean, I'm trying to think what's the best. Like in this case, I wanted it to feel like it wasn't too overworked, the lighting. I didn't want it to feel too fantastic or like marvelly, you know what I mean? I just wanted to feel like this is happening. It's kind of backlit because it's kind of an experiment in the corner somewhere in some facility. So I wanted the emphasis to be the backlight. So this, what you see here, is just that one light. I've turned off all the other lights that sits in the background of this scene. I can see if I can navigate. I'm a little bit nervous about moving around with this.
Zooming the camera out and
Yeah,
showing
yeah.
the whole setup.
But you can see there's the light on the right, and it's kind of just bouncing off it. I have a little bit of a bounce card here to give it a little bit of indirect bounce back up. But that's basically it for that, for majority of the lights up. We can turn on some of the other lights here.
I just want to take a second and remind myself and anyone watching that one well-placed light can do so much. And I like what you said there too. Like, this isn't made to be a perfectly lit area. It almost feels like we just kind of stumbled upon it. And lighting is a part of that, right? Like,
Exactly.
hey, there's just like a little work light in the corner. Yeah, storytelling. That's a great way to put it. Like, the little work light's on in the corner, and I had to like overexpose my camera just to get this shot. You know, like that's a different feeling.
This scene kind of shows it slightly better because it's a more solid object. It's less dynamic in a way in terms of the materials. But you can see this is like underlit. Like the foreground object is supposed to be the most important thing. It's quite dark, and that is partly because I want the screen content to show. But
the screen is a light in itself. You want to expose for that. Any real room situation, if you had a bunch of lights in front of your TV, it would also reflect and all that. So some of it's practical, but a lot of it is the storytelling too. Like, what is on the screen is more important than the TV, right?
Exactly. So here you can see there's the light from the scanner itself, because I can't really turn it off as easily as part of the shader. But here you can sort of see this is the influence of the HDRI. It's just there for some subtle reflections and indirect. So now I've turned off that main backlight. We can turn on some of the other lights here and look at them on their own. So this is just here. This is like a little bit off to the side. Behind, it's a slightly warmer light. It's just to kind of start to blend some of the gradients that you get on some of the surfaces, so that they have a little bit of a hue shift when it all comes together. But this one is slightly warmer, knowing that it's balancing against the kind of cold scanner light that's happening there. And then we have another light. Let's see. This is kind of like a foreground fill. It's also made to kind of cast take a little bit of reflection. Although this one was dialed back in comp later on. It wasn't used very much, but I wanted to give myself the opportunity to, I always render them with separate AOVs, so you can kind of dial in the influence of each light in comp.
You render out each light separately?
They come out as in the XR, like in AOV. They come out, so the beauty for each light, for example.
Okay. That's great. So you have control in the edit. Yeah.
I mean, the blue version of this that we looked at, we had the scanner that was fully lit, and we had this blue version. They come from the same render. It's just that I've just taken out some of the other lights for that export. So this one and wherever the other one was, this one, it's the exact same render. It's just that I have taken out some of the other lights in the other one. And here you can see the other lights have been brought up a little bit here, but my main intent on it was that I wanted the background to shine. I wanted the background to be the main driving force. And I tried to, as a general rule of thumb, I always try to do as much as possible with as little as possible. Because if you have like 100 lights, you're going to be very tricky to know what to change to make it better. So it's just
and using silhouette. I know I'm guilty of this. Like the power that a silhouette can have with just a little hint of reflection or a gradient going across is so powerful. And this that scene shows it, obviously. Especially if you got this big white background, like let the shape subtract from light.
Exactly, it's a negative shape.
Yeah, that's beautiful. That's awesome. Thank you for breaking some of that down. I'm gonna ask anyone watching to please ask questions in the comments, and what you kind of learned from this. If you're just getting into Houdini, maybe there's something here that you saw, you're like, hey, I got to play with this. Or if you've been using this forever, I'm sure there's something as well. This might be a great one to end on, Simon. I know
Yeah, we forgot to look at that. I forgot about
Yeah,
it a little bit.
you told me that the ending was also using some of the new tools in Houdini. So
Yes.
why don't we finish up with this one, because this is extra interesting. Is this the new is that Copernicus as well?
Yes, it is. So I mean, this was the kind of scrolling background thing we talked about. So here you can actually see some of the text. And this is all gibberish. I mean, if you read this, it's ridiculous. But this is kind of done, and it's actually like this code is done by ChatGPT as well. So like this is completely shameless. All I've done, I just asked it to write out about the gibberish for me in the style of the C64 with the stuff, and then I have a slider to scroll it. See down there.
That's amazing.
And then that gets recorded into Copernicus, which is like I'm rasterizing it like we were doing before with the stock pack. So this is the texture from that.
Yeah.
And then I brought it into Nuke and then kind of gave it a little bit of a treatment for the kind of CRT pixel effect. But so that's that. But then we also we did the end title here, the manifold type, which is a pretty cool. If I bring that up. So this is just written out here, text manifold. We then put some UVs on it. So I just used the triplanar UV projection. That's one of my tools, but it doesn't have to be that necessarily because it's just a flat object. It was just easy.
Yep.
And then we flattened the type. So this is now really, really small. You can't even see it. But if I click here, you can see the points that made it type. I just scaled it down to almost nothing and scattered points on the polygons. And that cuts it up. I flattened it so that when I scatter the points, when it cuts it up into chunks, there will be vertical cuts. And I have this scatter here that just is animated with the seed. So the seed is changing. You see how it can change the cut to create a little bit of a jitter in the effect. And then we also used a divide to kind of chop it up into little polygons, so it kind of cuts it vertically. And then we broke out each polygon here as its own polygon, so it becomes separated. It kind of becomes particles. And then we use this to stretch the bounding box as a fall off to kind of stretch them. And it's a way of mimicking the kind of scrolling consoles. So it feels like data coming together. It's kind of the meaning behind it. So that's the thinking there. And then using the UVs with Copernicus, like we looked at earlier, you can then take various patterns and tile them. So here's a cross again, thicker cross, various. This tiler is pretty cool. It has a bunch of different types of tiling that you can use, like to create a bunch of different stuff. And then using all of these things together kind of create different textures that kind of, based on the polygons as they change order and being recut, it creates a natural glitchy-ness that I wanted to represent the data, and then create a few different layers. I think, and there's a gradient here again, so that's the same that's been used for the fall off that kind of animates them up. So it's kind of like, in a way, this is a simple MoGraph thing where each polygon becomes its own clone, and it's just a linear fall off, pulling it back. That's essentially the effect. And then these layers came together. I'll see if I have it in here. Should have.
Yeah, but all that detail from the Copernicus stuff really helps sell that high data code, like almost matrix vibe, like.
Yeah, I mean, you see it there, and it's been composited afterwards, and stuff. And there's some of that console stuff as well. But cool. Yeah, the cool thing about it is you don't have to really. The render time is gone because it's basically just a rasterization, like a game engine kind of thing, but a very, very simple one. So you just get the data directly.
And you're doing all the blur and CRT and all that in comp, yeah?
Yeah.
That can be done anywhere.
That was done in Nuke. We use Nuke primarily.
Go to Panoply and to see the full version of Manifold and all the great work they do over there. They do, let this play. It's just beautiful work you guys do. And I've always loved looking at your career, Simon. The fact that I got to meet you right when you were kind of starting your journey, and you're now making some of the best stuff out there. It's just really, really cool. So please go check them out. And Simon, you know, personally from me, thank you for opening up your hard drive and your screen sharing and sharing some of these secrets here. I know every time I see something beautiful, I'm always asking the same thing, which is, how the heck did you do it? And now I get to call you and bug you, and you could actually show me. So I appreciate that, man.
Well, thank you for having me. It was, it's been a journey since we met. It's been a lot of years. But,
yeah, it's amazing. Even just watching this reel go through, I got 100 more questions. So I'm sure I'll hit you up here soon with some more thoughts. Oh, this is the full breakdown.
This is the film. You can click here and see it. And there's a bunch of cutouts from it.
Yeah, go check it out with all the amazing sound design. And please, if you're watching, especially at the end here, please let Simon know down in the comments. Give him a thank you from all of us for sharing this stuff. So there's a kind of a new idea here at Greyscalegorilla. I literally ask that question all the time. How do they do it? And, you know, I'm really lucky to be able to call up a lot of these artists and say, hey, let me ask them directly. And maybe you could share a little bit of how you made it and how you came up with it and what tools you use and what your thought process was and what lighting you use. So if you like that too, let me know down below. I'd like to do more of these. And Simon, thanks for being the first one too, to kind of say yes and break down such an amazing piece. I really appreciate that.
Nice one. Thank you.
Awesome. Well, thank you again, Simon. Where can people learn more about what you're up to other than the website we're looking at right now?
So yeah, I mean, Panoply is my main thing. We're obviously, that's my main thing. I have my own website that I haven't updated. Same projects more or less here anyway, but a few of my older works from Manners Machine Days and stuff is here as well.
Oh, that's the one you did the tutorial on too, down in the bottom right. It was like similar to that one, right?
Possibly. Which one are you talking about? This one? Oh, yes. Greyscalegorilla. This is, oh my God, I shouldn't be bringing this up. This is this is one of the first things I ever did, kind of at MV. So this is like, gosh, 13 years old. Oh, this is not playing back well, but this is short little bumpers, sponsored bumpers for TV.
That's amazing.
IQ, and it doesn't play because linear is shit. I don't know.
No, that's all right. We got 100 things recording too. So let's leave it at that for now, Simon. And because I know I'm going to call you again and hopefully have you break down some more stuff. And let us know, again, if you're watching, if you have any extra questions. Simon, thank you so much, man. I really appreciate you showing up and opening up your scene files in your hard drive. And I'm gonna have some more dumb Houdini questions down the road. I think I'm gonna dive in. So do you mind if I call you back and you can maybe show me some of the basics?
Go for it. I'm ready. I'll start setting up some files for you.
All right, I'm ready, baby. All right, thank you, Simon. I appreciate you, man. And we'll see you in another episode really soon. You want to wave with me? Goodbye.
Bye-bye.
Bye, everybody. Thanks again for watching, everybody. And let me know what you think about these interviews. And if there's anyone in particular you'd love to see here on Greyscalegorilla. All right, with that, we'll see you in the next video. Happy rendering. Bye, everybody.